You use numbers every day of your life. But what is numbers really? A number is a symbolic way to represent quantity, position, or size. It's a tool we use so we can compare things, measure them, and compute with them. This might sound abstract, so let's break it down with some concrete examples. First, numbers help us represent quantity, how many of something we have. Let's say we have a collection of objects. We count them 1, 2, 3, 4, 5. We represent this quantity with the number 5. Now we have a different collection. We count 1, 2, 3. We represent this with the number 3. Now we can compare these quantities. 5 is greater than 3. This is what numbers do. They give us a precise way to talk about how many. Numbers also represent position or order. Look at these positions: first, second, third, fourth, fifth. The number 3 tells us the position in a sequence. We can use letters too. A is first, B is second, C is third. Numbers let us describe where something is in an ordered list. Third, numbers represent size or measurement. This line is 5 centimeters long. This line is 12 centimeters long. We can compute with these measurements. 12 minus 5 equals 7. Numbers give us a precise way to measure and calculate. For clarity, the number 3 exists as a concept. It's the idea of threeness. We represent it with symbols. We can write it as the digit 3. We can write it as the Roman numeral III. We can write it as the word 3. These symbols are called numerals. They're different representations of the same underlying number. The symbol is not the number itself, it just represents it. Early humans needed ways to keep track of quantities. One method was using tally marks, 5 marks for 5 sheep. Another method was using physical objects like pebbles, 5 pebbles for 5 sheep. But what happens when you need to count 100? You need 100 pebbles. This gets impractical very quickly. We needed a better system for representing numbers. The Romans developed a numeral system using letters as symbols. But this system had a major limitation. Let me show you. Try multiplying 123 times 47. In Roman numerals, that's CXXII times XLVII. There's no straightforward way to multiply these directly. We need to convert to our number system first. CXXII equals 123. XLVII equals 47. Now we can perform the multiplication. 123 times 47 equals 5,781. If we convert the result back to Roman numerals, we get MMMMMDCCCXXII. The Roman system works fine for representing numbers, but it makes arithmetic incredibly difficult. The missing piece was place value. The breakthrough was the invention of place value. Look at the number 273. The 2 doesn't just mean 2, it means 2 hundreds, which is 200. The 7 doesn't just mean 7, it means 7 tens, which is 70. The 3 means 3 ones, which is 3. We have hundreds, tens, and ones. Add them together, 200 plus 70 plus 3 equals 273. The position of each digit determines its value. This place value system only needs 10 basic symbols: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These 10 digits are called digits. From just these 10 digits, we can represent any number. The number 25 uses the digits 2 and 5. The number 847 uses the digits 8, 4, and 7. Even 10,000 only uses the digits 1 and 0. Combined with place value, these 10 digits give us infinite possibilities. Let me summarize the 3 key terms we've covered. A number is a way to represent quantity, position, or size. A numeral is a symbol representing a number, for example, the digit 5, the Roman numeral V, or the word 5. A digit is one of the 10 basic symbols, 0 through 9, that we use to build numerals. The 5 in both the number 5 and the number 567. In the rest of this series, we'll discuss various types of numbers: natural numbers, integers, rational and irrational numbers, and so on. In our next video, we'll discuss the natural numbers. You'll be surprised at what you'll discover in the next video. Like this video and subscribe so you don't miss out. Also, subscribing encourages us to continue making these videos.